Solving radical equations or a radical equation is any equation that involves an nth root. So these first two examples here, where we have a cube root and a square root with a variable underneath them, and it's an equation that we have to get x by itself. These are excellent examples of beginner radical equations. So what we want to kind of keep in mind when we're doing this is that what is the opposite of an nth root? So what is the opposite of a square root, or how do I undo a square root? Well, I'm going to square it. But what if it wasn't a square root? What if it was a fifth root? How do I undo a fifth root? Well, I raise it to the fifth power because fifth roots and fifth powers are opposites. That's what they were designed for. So we're going to use that fact that exponents are the opposite of radicals for to undo those radicals and kind of end up solving these equations. So what are the steps that we need to keep in mind as we are solving a radical equation? The very, very first important step is to isolate the radical. Remember, we can't use any solving rules until we have the thing that we're trying to undo by itself. The thing that we're trying to apply the rule to, we have to have it by itself on one side of the equation when everything else is on the other side of the equation. Then we are going to raise both sides, the whole side, not each individual term. Raise both sides to the appropriate power, depending on whether you have a square root, cube root, fourth root, fifth root. We're going to solve, and then here's the most important part. The second most important part, I should say, is you should always check your answer. With radical equations, they are notorious for giving you two answers, but actually when you go back and check, only one of them works. And it's just kind of the nature of a radical equation that that's what's going on. So let's look at these first two examples and see if we can apply these four steps. So step one, is the square root by itself on one side of the equation? Yes. Step two, we're going to undo the square root. What's the opposite of a square root? A squared. So we're going to put parentheses around the entire left-hand side and the entire right-hand side and square both sides. On the left-hand side, the square root and the squared cancel, and we're left with just what's on the inside, which is 3x plus 5. On the right, we're going to square 12 and get 144. And from here, it should be a fairly simple solve. So 3x is equal to 139. So x is equal to 139 thirds, which does not simplify. Now, if I plug 139 thirds back into here, trust me, I have done this problem many times before, and it does actually work. So we've checked our answer. Let's look at this next one. What we have here is cubed root of 2x minus 4. Minus 2 is equal to 0. What's a little bit different about this one versus the last one is that cubed root is not by itself. Remember, we have to isolate first. So we need to move this negative 2, this minus 2, over to the other side by adding 2 to both sides. That will give us the cube root of 2x minus 4 is equal to positive 2. Now that the cube root is isolated, we're going to put parentheses around the entire left-hand side and the entire right-hand side and ask what is the opposite of cubed root? A 3 exponent. So we'll raise both sides to a 3, or cube both sides. On the left, cubed root and cubed exponent cancel. And so we are left with 2x minus 4, and 2 cubed, don't freak out. Remember, that's just 2 times 2 times 2. That's 8. And from here, we can solve. So 2x is equal to 12. So x is equal to 6. And if I throw that back in here, 2 times 6 minus 4 under a cube root minus 2, is that equal to 0? Okay, 12, 11, 10. Is the cube root of 8 minus 2 equal to 0? Well, the cube root of 8 is 2. That is a correct answer. So we're going to keep x equals 6 as our final